All right, so I'm going to use that last method I talked about last class. Anybody remember what it was called?
Was that the weird one?
Mm-hmm, the weird one.
The Euclidean?
Euclidean algorithm, yeah. So Euclid's algorithm said to basically define the GCD, you just do some divisions and pay attention to the remainder. So let me get my tools back for this one. There they are. I'm going to find the GCD first. And so Euclid's algorithm basically says take 21 into 24 and then write it down with the quotient and the remainder. So 24 equals, oops, writing today, better. 1 times 21 plus a remainder of 3. So 21 goes into 24 one time and the remainder of 3. And then I shift the divisor and the remainder over. So now I take the 21 and I take 3 into it. So 3 goes into 21 7 times, and then there's no remainder. And once you hit that 0, whether it happens in 2 steps or 1 step or 10 steps, that 0 then says, hey, the previous remainder, that right there is your greatest common divisor. So the Euclidean algorithm is usually pretty darn fast. And you could either write your division this way, or you could write it long division style, whichever you prefer. For some reason, I like to write it this way. Now, once I have that, I can use another fact that if I have 2 numbers, their product is the same thing as the product of the GCD and the LCM. So in other words, if I know the GCD, then all I have to do is take my 2 numbers, 24 times 21, multiply them, and divide out the GCD, and then whatever's left has to be the LCM. So let's say 3 goes into 24 8 times, and now I just have to take 8 times 21, so let's see, 8 times 2 is 16, so that'd be 160 plus 8, so I think 168 would be the lowest common multiple, according to that method. I'm just going to double check by doing the prime factorizations, which is another method that we used before. So I would make a factor tree for 24. 2 goes into 24 12 times, and 2 goes into 12 6 times, and 2 goes into 6 3 times. And so I just make a note, either using powers or not. I'm going to use powers here. 2 to the 3rd times 3 is that one. And then 21. 2 doesn't go into it, but 3 does 7 times, and since 7 is prime, I'm done. So that one is just 3 times 7. So to make the GCD here, I have to take the lowest power of the common primes. And in that case, 3 is the only common prime, so I just take 3. And let's say I took that one right there. 2 ways to look at the LCM. Either you could say the LCM is everything left, or you could take the LCM by taking the highest power of each prime present. So there's a 2 present, and it's 2 to the 3rd. So the LCM has to have a 2 to the 3rd in it. There's a 3 to the 1st power, so I have to take one of those. And there's a 7 to the 1st power, so I have to take it too. And so that product right there is going to be the LCM. Which if you check, it should come out to that 168 that I found on the previous page. So a couple ways to do it. What's another way I could find the greatest common divisor? We went over at least one other method last week.
You could do the 24 and 21 and then do like 1 times 24.
Yeah, list all of the divisors of each one and find out the common ones and then pick the biggest of the common divisors. Yeah, that'd be one way. So we could do it by listing. How another way to find the lowest common multiple?
Listing out like the multiples of each number.
Yeah, start listing multiples of 21, start listing multiples of 24, and find the first place they match. Yeah, so lists can be done in both ways. And usually developmentally, lists are where you start off with. just getting that idea of these are the multiples. Oh, look, they have some in common. Okay. And then in one case, we can find the lowest common one. In the other case, it's more interesting to find the biggest of the common ones. Okay. So those are important tools for a lot of things in math. In particular, we're going to use them for fractions. And so that's the big thing we're going to move to next. So before I go on to fractions, did anybody get stuck on any of the homework problems in the 4.1, 4.2 review or section 4.3? All right. Okay. On we go. Time for fun with fractions. And that is actually, this is what the course name should be instead of Foundations Development for Mathematics 2. It should be fun with fractions because that's the theme of the entire quarter. The whole point of doing the number theory was to work with fractions, and then next we play with decimals, which are a special kind of fraction, and we play with ratio and proportion, which are still fractions, and we play with percents, which are still fractions, and then we do probability, which is all about fractions. So, fun with fractions. So you're going to start us off. What I need you to do is think about what does it mean to be a fraction? Write one statement about that and draw one example. What does it mean to be a fraction? Give me some words, give me some kind of picture example. All right, so anybody want to take a stab? What is a fraction?
Not a whole number.
Not a whole number. That's the part. Not a whole number. Okay, what else?
It's a portion.
A portion. Okay.
Part of a whole.
Whole. Okay.
I said it's something that's divided.
That's divided. Okay. something that's not here yet. All right, so everyone draw some kind of picture? Did anyone draw a picture kind of like either of mine? Anyone draw a picture that's not really like either of mine? Really? Okay. So on what is a fraction, you nailed almost everything I wanted to see up there. So we'll come back to that. I'm going to draw another picture. When I was a kid, I learned like to try and draw a boy and a girl. That was what they looked like. I've progressed a little bit, not too much. It was a little quicker. That's a picture of a fraction. What fraction did I draw there? Write something down. Don't say it yet, just write down what fraction you think I drew. Anybody want to tell me what fraction that is?
1/3.
We got, what is it?
I said 1/3.
It's 1/3. You said 1/2. Okay. Anything else?
I said 1/3 or 2/3.
Or 2/3, okay. 1/2. Can you tell me about that?
I just did it, the one guy, 2 girls.
Oh, so like ratio of boys to girls, guys to girls, yeah, okay. Okay. Is that idea represented in the ideas back here? Portion, something is divided, sort of. So I think to take that example on, we might say like the idea of a ratio. So a ratio is just a comparison of two things with division. So here we're just comparing boys to girls. It doesn't really make sense to talk about like, what did division mean to us before? Like how many groups of one thing or another, like 6 divided by 2 is 3 because there are 3 groups of 2 in 6. But that doesn't really work with the boys and girls thing, does it? There are 2 groups of girls and 1 boy. What? No, it doesn't work. But it's just, we're using division, it is a fraction, and it's just a different way to do it. But this is super important. A fraction is a division. And all the time in college, people come to me and they say, I can't figure out how to do fractions on my calculator. And I tell them to hit the division button. And they're like, really? Like they forgot that part about fractions, that fractions really is division. I mean, yeah, it's part of a whole, it's this weird thing that's hard to calculate with. But there was a disconnect somewhere. And this happens with a lot of people, that they're shocked that the division key is, like if they want to do 1/2, they just go 1 divided by 2 is 1/2. And it's not uncommon that people don't make that connection, even though they kind of know it somewhere in there. They just kind of lost track of it. So that's important. So fractions mean a lot of different things depending on the context, the person, the day. But things that are all part of being a fraction. Often we think about fractions as not being a whole number. We're going to expand that a little bit. A portion, a part of something. So what fraction was I trying to draw in this figure on the left? Probably a half. It looks pretty much like a half to me, and I was hoping most people would recognize that as a half. What was I trying to draw here on the right side? A quarter? I thought I was trying to draw a third, but then after I looked at it, I was like, no, that looks more like a quarter. Like if I continue this line that way and this line that way, yeah, I accidentally drew a quarter. I meant it to be a third. Thirds are kind of hard to draw. Fifths are hard to draw. Even things are easier to draw. And we'll play around with that idea over the next week or so. So although I meant it to be a third, it looks more like a quarter. Yep. Okay. So I'll go over what I think a fraction is. So when I think about fractions, I think about equal parts of a whole. And we often forget that equal parts, and that's important. So back to my circle example. This figure here, this circle has 2 parts. That part right there, And it's got this part right here. Suppose this is pizza and you're really hungry. And you get to pick one piece. Which piece are you going to pick? The red piece or the blue piece? You're going to pick the blue piece if you're really hungry. So, so we can't say that since there's two parts, that's 1/2 and this is 1/2, because that misses out on the equal parts of a whole. So that is going to be reinforced early on that we're looking for equal parts of a whole. Other thing, how many people drew a circle on their paper? We got 1 circle. We got 2 circles. 3 circles. Whoa. 4 circles. 5 circles. Oh my gosh, it's unanimous. Circle is the most popular object to draw when you're making fractions. However, circles are hard to draw for most people. They're especially hard to cut up into pieces. So my recommendation is to use cakes instead of pies for circles. I love circles, seriously. But it's easier if you consider a cake to be something that's rectangular. It's way easier to draw rectangles than it is to draw circles. And they're easier to cut up because you don't have to worry about going through the center. And so I could quickly make halves. I can quickly make quarters. And even thirds aren't that bad. So draw yourself a square or rectangular cake and attempt to cut it into thirds. Usually what I do is I make a couple of marks on one side, attempting to make one line into thirds. And if that looks good to me, I just continue those lines through. Not too bad today. Next, draw a circle and attempt to cut that into thirds. And it's usually when I turn my head and look at it and I rotate and think, oh yeah, it doesn't look good from that other direction. I turn your paper upside down and look at it. Still look good? Or is it a little sketchy? Just, you know, when you change the perspective, you think about it differently. That reminds me of another fun article I read a while ago, kids' perceptions of things. If you show them things like this, what are they going to say they're looking at? Triangles, right? But then all of a sudden you draw one like this, and they're not so sure what to call it now. Because most of the other triangles they've seen in books, they all had one side that was in line with the bottom of the page. And then you throw one that's not, and they're like, I think it's triangle. Not really sure. Same thing with square. If you draw a square and an angle instead, they're going to be like, nah, that's not a, ooh, well, it's harder to draw. But they're going to say, that's not a square, that's a diamond. Right. What's a diamond exactly? Anyway, that's not really a square either. All right, back, side note. Wrong button. Okay, so back to fractions. So we got equal parts of a whole. And the equal part is definitely important because if we don't have that, then it's hard to talk about it. It's a comparison with division. That's an important thing about fractions. Fraction is a division. And you'll start talking about fractions really early in the curriculum, but you won't start manipulating them until later. So you'll talk about half of something, a third of something, right? That idea of division. But writing things like this won't happen until later. So 1/2 is often written like that. It can also be written with a slash instead of that horizontal bar. And that's the same thing as 1 with this crazy symbol here, divided by 2. So we have different ways to write it. And think about that comment I made a little while ago that a lot of people don't know that to do a fraction on the calculator, you just hit the division button. What symbol is usually on a calculator for the division button? The first symbol, the second symbol, or the third symbol?
It's the second one.
It's often the second one, sometimes the third one, but never the first one. Okay, so there's kind of calculators lead people to stop thinking about fractions as division, but they really are division. So these symbols all right here, they're pretty much in line with each other. We tend to read left to right, top to bottom, and so there's a nice flow to those. But then we have this fourth symbol for division, and we talked about this last term. I just want to remind you, it's what I call the goes into symbol. And sometimes we need it when we're working with fraction. So here I have 2 goes into 1. Right, the symbols get, the digits get reversed, or the numerals get reversed in their position. It gets read.
Side notes,
Yeah.
mine actually does. Not in the normal, but right here, you can do.
Oh, it has the 1 over button. That's true. Yeah, good point. So many calculators, scientific type calculators, they'll have what's called a reciprocal button. And that button will usually look like this, 1 over x like that, or it'll literally be stacked like a regular fraction. And so what did you got? Is that an iPhone type calculator?
Yeah.
Yeah, so the iPhone calculator shows this one right here. I'm not sure what Android calculators show. Let's see what the Google calculator shows. I'm kind of curious what the Android show. So I said number 2. Do we have the reciprocal button here? I don't see it. Oh, it's probably just the inverse right there. Nope. That's not it. Oh,
They have the 1/x, not 1 over
It's the
x.
sideways one, the diagonal one. Okay. Oh, that switches between radian. Oh, I forgot. For some reason, this is interesting. The Google calculator stopped working in my version of Chrome on this computer. It's kind of weird. Oh well, I don't see the 1 over x key here, but most calculators have that, scientific type ones. Okay, let's see, other important facts about fractal basics that I wanted to mention, and we'll start playing. Talked a little about ratio, oh yeah, a couple of others. So going back to models we talked about with multiplication, which is related to division, there's part of a whole versus part of a group, and they can have slightly different interpretations. So part of a whole is that idea of mathematics like continuous. You can draw something without lifting your pen, like paint on a wall. So part of a whole is where we're shading something in. And so maybe I want to shade in 1/4 of that square. Compared to part of a group where I have individual objects, not some pie or cake that I'm cutting up, or part of a wall that I have to paint, and these could be people. And one of them is a little different. So this is an idea in mathematics when we talk about a group of distinct objects. That's an idea called discrete in math. Versus this picture up here goes to the math idea called continuous. And we'll talk more about that after that, at the end of the decimal chapter, discrete versus continuous. Discrete is something that's countable. So I can easily count up people in a room, count pencils. Counting the paint on the wall, that gets a little weird. Right? There's not individual things of paint I can count. It's just some amount of paint that went on the wall. I can weigh it. I can figure out how much liquid it was, when I started with it, but it's different than counting 1, 2, 3, 4. So discrete is the idea of counting. Continuous is a more complicated idea that we evolved in math. The division problem is an interesting one for a fraction. So imagine that I have 2 chocolate bars. And let's say they're the same size. Let's see if I can duplicate this sucker. Copy. Ooh, what did I do? Draw chocolate bar. And then copy it and paste it. Okay, so now I have 2 chocolate bars. They are identical. But I have 3 people that want to eat this. So here's what I want you to do right now. Draw those 2 chocolate bars to the best of your artistic ability and attempt to cut them up so 3 people can share equally. So what I'm imagining doing is cutting each of them into thirds. And how many thirds does each person get? 2 thirds. So I tried to do it with 2 quick cuts in the beginning. So this was my first cut, that was my second cut. So here's the 2 thirds for one person. Here's the 2 thirds for the other person. And here's the 2 thirds for the third person, right there. So that is a fraction, right? It is equal parts of a whole, but in this case I had more than one whole. The numerator was telling me I had 2 wholes. Split among 3 people. So kind of a different interpretation, a slightly different picture, but it goes back to that fraction as division problem. And then one other way to think about fractions is in terms of, it's not a whole number, but it is a number. So a fraction can be considered one of 2 things, either a point on the number line, or similarly, a distance. So for example, if I put a mark right here, I'm trying to put a mark, a point, at the position where 1/2 would live. I could come over here and try and put a couple of marks there. And this second one I'm trying to indicate would be 2 2/3 on the number line. So often we think about a fraction as part of a whole, but it can be more than that, because 2 2/3 isn't part of a whole. It's a position. It could be considered a distance from here, ending up there. If I reconsider the whole number line in terms of thirds, how many thirds are in a whole? 3 thirds, right? So I start here and I have 1, 2, 3 thirds to get that whole, 1, 2, 3 thirds to get that whole, and then I jump 1, 2 more thirds to get to that position right there. So altogether I have 3, another 3, and another 2. So this would be what, 8 thirds to get to that position? So we've got mixed numbers, kind of fraction we have. These are called improper, which I've really never liked the name of that. Oh, it's improper, I shouldn't do that. So often I call them top-heavy. I'm sure there's arguments against that too. Anybody have an example of why an improper fraction might be better than a mixed number, or a mixed number might be better than an improper fraction?
Easier to divide.
What's that?
It's easier to divide.
In which form?
Improper.
The improper, yeah, it's just a single division. Can someone read this number right here to me?
2 and 2/3.
What was it again?
2 and 2/3.
2 and 2/3. It's not just 2 2/3, it's 2 and 2/3. And that's important because we literally mean 2 plus 2/3. We just ignore the plus there, but it is part of that number. So mixed numbers are kind of dangerous, especially when kids get to algebra, because what does no symbol usually mean in algebra?
Multiplication.
Usually we multiply. What does no symbol mean here?
Addition.
Add, yeah, we get something weird going on there. Entering something like that in the calculator is awkward. It really is, we say and, we mean and. It's really a plus there. So check this out. So I live, I live 4/3 miles from here. Does that sound odd? I live 1.3 miles from here. That sound better? So usually when we're describing a distance to somebody or a number, mixed numbers tend to make more sense to our brains. On the other hand, if I need to do a calculation, improper fractions are way easier to work with than mixed numbers. Addition, subtraction, multiplication, division, way easier. So they both have their pros and their cons. So improper, nice for calculations. Mixed numbers are nice for communication. Use them. So I think we've got that pretty well nailed down. So we're going to play around with some activity stuff. I posted so far on our course page, homepage, that we're going to do activities 6.1 and 6.2. Would anybody like one of those packets? I think I printed some. Didn't I?
Oh, really? I think I
Oh,
saw
I forgot to print them. Okay, raise your hand if you want some. And to everybody, right? Except me, you got some, okay.
I was gonna buy it.
So I think I put a link to it here. I'll just put it now. So we're going to take a look at activity 1 and probably 2 today.
Do you want our other activity? I didn't put it in on.
Yes, if you have an activity to give me, I've got a pile going right here.
When's our first test again?
When we're done with chapter 6, so probably 2 more weeks. Okay, that's the wrong.
Because that's what that looks like too. You can grab one of those right here.
Okay. Thank you.
Yeah, there's some toys up here. There's some in little plastic boxes. If everyone can grab one little plastic box. And I'll have this up in paper for you in just a moment. And then I'll get the big toys for everybody in just a minute.
So it's gonna be like the 31st. 2 weeks from today, or will it be Monday?
So let me see. We've got 6.1 today, 6.2 next class, 6.2.
Oh, thank you.
It is, what did you say, the
31st is Wednesday or the 29th?
probably the 31st. So those are coming up. So the first thing we're going to do with these activities is a couple. Activity 1 is what is a fraction. And we're just going to play around with some different toys. So you've got color rods, which I show on the video here. Here. So color rods, sometimes they're called Cuisenaire rods because Cuisenaire is a company that makes classroom materials, and they were one of the first big marketers of this kind of toy. And they come in 10 colors with 10 sizes. So what I'd recommend right now is just in front of you with the color rods, build a set in ascending or descending order, one color of each. That's going to be your key for working with these here. So I'm going to copy that into my screen. Oops. Page. So we're going to need a key to play with these guys. And then we're also going to play with another kind of thing called pattern blocks, which I'm going to hand out now also. And the pattern blocks come in some different. I think those are the ones we can play with there. Yeah, so for the pattern blocks, grab a few hexagons, a few trapezoids, and several of the blue rhombuses and many of the green triangles. We need to just move that. Okay, so let's sample this. Ooh, feels like there's more than one copy there. Oh, just a lot of papers.
Just
You don't need the squares, but you need some with the red trapezoids.
Thank you. Sorry. No, you're fine.
So when this box comes around, oh, here's some more here. Some going on the other side. You want these, some of each of these four shapes on the screen there. Grab some.
Thank you. Thanks.
And so I think the most important thing with fractions is just getting used to comparing fractions, with building them by hand.
Thank you.
Drawing them is super important too. And although earlier I kind of counseled to not do too many circles, we still want kids to practice drawing circles. We want to practice cutting them up. But just on the fly, it can be kind of frustrating sometimes trying to draw a nice picture. And some kids are better at it than others. So sometimes drawing squares instead of circles can kind of equal out the playing field for those kids that don't seem to draw as well, don't have the dexterity down yet. Everybody get some of each now? We have a bunch of different things. So these are called pattern blocks because you can put them together and make cool patterns. Which, oh, Ashley didn't get some. No wonder she's not making crazy patterns yet.
Oh, yeah.
Oh my God.
We need some of these too. And I have foam ones too, but I like the feel of the wooden ones better. But if anyone likes foam better, they're up here. So just some naming conventions so we're all on the same page. So what should we call our yellow thing up here?
Hexagon?
Hexagon, nice, yeah. That'll be a hexagon. How about the red thing?
The
Trapezoid. And the blue thing?
rhombus.
A rhombus, nice. And a triangle. And more more technically, it's a equilateral triangle, but we'll just call it triangle for now. So we're just going to name so we can differentiate between the things. And depending on the age group, you can just call them, you know, the yellow shape, and the red shape, and the blue shape, and the green shape. So on the activity 1, it's just going to start off with just comparing these objects. And bless you, it's super important with fractions that every time you play with them, with kids, you have a key as to what's a whole now. And typically what we'll do is we'll let the hexagon be a whole, and then the other things are parts of a whole. And so the first few questions here are about that. The trapezoid is what fractional part of the hexagon? That means the hexagon is the whole, what part is the trapezoid? We would say?
1/2.
1/2, yeah. It's 1/2 of the hexagon. And then the blue rhombus is what part of the hexagon?
1/3.
Okay. Now here's an important part. We can look at it and see that third because we have so much experience in life and math. But for kids, they really need to stack them up and do it. So just right now for fun, take some of those trapezoids and sit them on top of. Because one kid might throw them together like that and say, you know, I just don't see the third. It kind of almost fills half, right? On this 3D, on this virtual one, I can rotate them. I got that in the right spot, not quite. There we go. So I can see that, oh yeah, 3 of them make a whole. It's not quite the orientation yet. And whenever possible, I'd rather my kids play with the real toys than toys on a computer. It doesn't want to go any higher. Fascinating. Come on, get up there. All right, you get the picture. So it's a third. And how about the green triangle? So it would be 1/6 because 6 of them fit on there. We want to put them on there and show that. But then in the next couple of questions, we shift focus. And instead of, in question 4 here, instead of the hexagon being a whole, now the blue rhombus is a whole. So if the blue rhombus is a whole, the triangle is what fractional part of it?
1/2.
It'd be 1/2. Yeah. And again, that's something we can grab the toys and we can see it. You can stack them up on each other. How about the triangle? What fractional part of the trapezoid would it be?
1/3.
It'd be a third. Yeah, beautiful. Ah, nice pattern. I need to go for that. All right. So on the next one, we're just going to compare shaded versus unshaded. So just make a note as to what you think the shaded part is versus the unshaded part. So just a little warm up, playing around with different shapes and fractions. So on the next page, things are going to get more interesting. And they're going to get more interesting because we're going to shift what a hole is. So at first, we're going to take the orange rod as being a hole. With the color rods, the nice thing about the orange rod being a hole is that since there's 10 colors, if the white one is a 1, then it's a 10. So you can easily play with decimals if the orange one is a whole, which is kind of nice. But if you wanted to play with thirds, the orange one's not so good. Because is any of the other shapes 1/3 of the orange one? No, none of the other ones are, so that doesn't work out so good. What would be some good shapes if we wanted to talk about, what are good colors here, if we wanted to talk about thirds?
Third one, the green
The
one.
light green one? Yeah, so if we labeled these as 1, 2, 3, the light green one would be nice to talk about thirds. 4, 5, 6. The dark green one would work for thirds too. How come? Because 3 is a divisor. Yeah, any number 3 is a divisor would work good here. So 6, 7, 8, and then the blue one would work okay for thirds because 9 is 3 times 3. So you can choose which one gets to be a whole depending on what kind of numbers you're working with, and then use the color rods to go from there. But can you see what I mean? That you always have to have a key saying what's a whole at this moment, otherwise it gets super confusing. And switching back and forth often in the same lesson can be confusing too. So you want to be careful about that. So I'm going to end this recording here and start a new one in a minute. So your goal now is to try and come up with the fractions that represent the comparisons here for each of these, and then jumping into the next part. And then we'll compare notes in just a minute. But start working on it with yourself and then checking with your neighbor.